Welcome back, mathematicians. Today we're going to go over understanding quartiles and interquartiles. But before we do that, I wanted to take a look at a good example of measuring the middle and how things vary, and then some definitions that we need to understand quartiles. Um, so because this is a digital book, I can't flip towards the next page to keep referring to these definitions, but I'm going to be using them throughout the video. So in your book, feel free to flip through um, back to this page so you can take a look at the definition if you forgot what it was. Let's zoom right into here to this concept of measures of variation. So you learned in sixth grade, or possibly sooner, that the mean is another way of saying the average of a set of numbers is when you take the sum of those numbers and then you divide by the amount of numbers you have. So here we have two football teams. We have Team A and we have Team B. And you'll notice that these numbers, which represent the height of the players in inches, vary somewhat. However, right, their um, their mean are both 76 inches. So you have one guy here in Team B. If we take a look at Team B, and this player is 82 inches big, which is huge. So this player is much taller than the mean, which is 76 inches. So that means that he's kind of like a, not necessarily an outlier, but he makes that team, um, he kind of carries the height of that team. If you were to remove this player, okay, then 70 is going to be carrying it really down. So what you have here is kind of the reason for Team B and Team A having the same mean is that in Team A, they're all kind of around 76. So 73 is a little bit higher, 78 a little bit higher. 73 is a little bit lower, 78 is a little bit higher, 78 is higher, 75 is lower, right? So they all kind of hover around 76. But if we look back at Team B, we've got 82 that really makes it jump up, and we've got 70 that really makes it go down, and all of the other numbers are around 76. So there can be some variation in your data in those numbers and still have a mean that's the same as like another team. So that was a pretty good representation of an actual like team of football players, right? Maybe the quarterback's really tall and everyone else is really short, but their mean height is still equal to the mean of, the height of another team who's all the same height. But that quarterback that's really tall, he's going to be able to do a lot of stuff because he's taller than everyone else. He just throw over them. So I thought that was really neat. All right, now let's scroll down a little bit and talk about these definitions. So the range, that's the difference between the largest number and the smallest number. So if you look back at the example from above, we've got these numbers here. Okay, I'm just talking about Team B. The largest number there is 82, right? That's the tallest player. The smallest player is 70. So if you were talking about the range of the height of the players in Team B, we would give a value of 82 minus 70, which would be 12. So that means that the range is greater in Team B. If we look at Team A, the largest number is 78, and the smallest is 73. 78 minus 73 is 5, so the range is only 5. So typically when you have a smaller range, that means that your data is kind of more centralized. Okay, if you have a larger range, then it's kind of spread out more. The next thing we want to look at is the median. The median is the middle value when you order the numbers in ascending or descending order. I will say when we talk about statistics, usually we do ascending order. So we start from the smallest and we go to the greatest. So what I'm going to do is cross out descending, but I want you to know that it would work mathematically. And we'll have an example of using a median when we talk about quartiles, and we're going to talk about quartiles next. So scrolling down a bit more. A quartile is like separating all of your data into quarters, so like 25%. So your first quartile has 25% of your data. Your second quartile has the next 25%. Okay, if you were to combine these two quartiles together, it shows the bottom 50%. Okay, quartile 3 is the next 25%. Quartile 4, the next 25% of your data. So what you're doing is you're taking your list of numbers and you're just separating them into different parts, but each part tells a story. Okay, this middle here, this middle 50% is called the interquartile range. Okay, it tells you what the middle 50% looks like of your data. Now we find these numbers, okay, by taking the median, by finding the middle, and then we separate. Okay, and then we find the middle again, and then we separate. And you'll see that in the examples that we do. But I just want to make sure that you have this to refer to. Okay, so the quartile separates the list of numbers in ascending order by finding the medians. So this number here is called Q1. This number is called Q2. This number is called Q3. Those are all medians, and you're going to see how we get those in the following example. Just a quick example of finding the range of a data set. So the range is the largest number subtracting the smallest number. So if we look at all of this data here, 68, 73, 64, 70, right? You can list them out. What you want to do is figure out what number is the smallest and what number is the largest, and then you can do your subtraction. It's easier to do this when the numbers are in order. In this case, they're not, so you're just kind of looking. So you look at 68, right? First, let's find the highest number. You look at 68. 68, well, that can't be it because 73 is the highest, right? 64, still not higher. 70, still not higher. 86. 86 highest, right? Am I beating 86 yet? Keep going, keep going, keep going. 89. Now I'm beating 86. So 89 is the highest. 82, 60, right? So 89 must be my high number. So if I'm finding the range, my highest number is going to be 89, or my greatest number. And then we repeat the process for finding the lowest number. 68 is pretty low. Still lower than 73, still, 64 now. That's my lowest. Right, you keep going on. 54 is my lowest. Keep going, keep going, keep going. And that's it. So it looks like 54 is my low number. And of course, as this was ordered from least to greatest, it'd be easy to find the range because we'd be taking the one on the right and we just subtract the one on the left. But it didn't give it to us in order. So then of course we do 89 minus 54 and we get 25. So the range equals 25. And what they're asking for is the history test scores of 10 students are, then list them out, find the range of the test scores. So that means that the highest student scored 25 points better than the lowest student. Moving on to example 2, if we just go down the page here, find the quartiles of a set of data. It says the data below show body weights in pounds recorded at a healthy screening of a group of people. Find the first, second, and third quartiles of the body weights. Okay, so in order to find quartiles, we have to first order the numbers. Okay, and we want to do it from least to greatest. So as you do this, it's important not to scribble out data because you might need it again. And if you scribble it out, you might lose it. So what I like to do is just circle it. Okay, so I'm going to list out my numbers here, and I'm looking for the smallest one. All right, so it's not going to be 100. It's not going to be 155. 98 is pretty small. 94. 94 looks like it's my smallest one. So I'm going to circle 94. Because I'm using that number, right? So I'm going to write 94. Now, you want to look, are there any other 94s? Because there can be repeats. And it doesn't look like there are any. So next we want to find 95. Is there a 95? There is a 95. Okay. And I'm just going to keep on going. So after 95, is there a 96? There's not, but there is a 98. So we circle 98. And we keep going. And you're going to list out all these numbers. You don't need me to list them out for you. Let's go ahead and pause the video. You can do that. Now that you have your list, you want to make sure that you have all of the numbers accounted for. One way to do that is to keep circling. Another way to do that is to count. So how many numbers are supposed to be in here? So let's see, there's 2 rows of 1, 2, 3, 4, 5, 6, 7, 8, 9. So I should have 18 numbers. So let's count them out. 1, 2, 3, 4, 5. And you count out yours. And you make sure that you also have 18. Now after you've counted them out, I'm sure that you found that you weren't missing any data. So we're going to go ahead and we're going to separate them into groups. So we have 18 numbers. If we want to separate them into 2 different groups, we're going to split them in half. And that's going to become our middle quartile. Well, we can count, right? 18 is 9 and 9, so let's see my 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is right here. Okay, that's my breaking point. Now, notice there's no number there. I need to give a number for a quartile. I can't just say it's a line, right? I have to actually have a number. So what I do is I take 126 and 138 and I find the mean between them. So 126 plus 138 divided by 2 is 132. That is my middle quartile. And if I'm looking left to right, it's called quartile 2. And now we're going to look again, okay? Because we have the middle quartile, which is quartile 2, okay? 2 kind of represents the 2 halves. You can think of it that way. But we want quartiles, right? It's quartile, so we should be 4 groups. We should have 4 groups. So now we're going to separate each of those groups into 2. So let's look at the left. We have 9 numbers. That means that I should have 4, 4, and then that 5th number is going to be in the middle. So kind of think of it this way, right? 94, 126, 95, 125, 88, 124, 100, 118. So 117, that is going to be my first quartile because it represents kind of where the cutoff is between the first 25%. And now I erase those lines here, and we're going to find, so we have quartile 1, which is 117, quartile 2, which is 132, and we're going to do the same to the right side. So I've got 138 and 170, 140, 160, 142, 160, 147, 155, and then 153. That's the number in the middle. That's my third quartile, 153. So to answer this question, okay, all I'm going to do is I'm just going to list out the different quartiles. So I'm going to say quartile 1 is 117. Quartile 2 is 132. Quartile 3 is 153. Okay. And if you kind of think about that as that box that we talked about, or if you look back at the first page, so think about that box that we had. Okay. 117 would be my first quartile. 132 is in the middle. And then 153 is here. And then we talk about each one of those being percents. So this is 25%, 25%, another 25%, another 25%. And when we're looking at this data, okay, we can say that someone who weighs below 117 is in the bottom 25%, okay? You could say someone that weighs below 132 is in the bottom 50%. Someone who weighs greater than 153 is in the top 25%. Okay, so that's the reason why quartiles can be really important, is when we talk about the percentage of data that is greater than or less than the numbers that we're looking at. All right, find and interpret the interquartile range. So if you go back and you look at the first page, the interquartile range is that middle 50%, okay, that doesn't really have a number with it. So we want to try to find the range between the middle 50%. In order to do that, we need to find all the quartiles. Okay, so you're going to take this data and you're going to order it from least to greatest, just like I did already. Okay, so you can copy down my list if you want. And we're going to start separating this data into groups, right? So there are 3 rows of 5, so there are 15 numbers. That means that the 8th number should be the middle number. So let's take a look. 5, 11.5. If you like doing it this way too, you can do it this way. And you're just kind of checking one off on the top and the bottom as you go along. Right, so that the only one left is 8. 8 is in the middle. And then you can just erase those lines that you made. Excuse me. So we can go back and work with our original data. So 8 is Q2, which doesn't help us a whole lot because we're not using Q2, but what it does is it separates the data for us. Okay, so now I know where to find the first quartile and the second one. So just like before, okay, I'm just doing the group within a group. So 7. 7 is going to be my Q1. And then I find my Q3. So notice I'm not using this middle value here because it's already being used as um, my inner quartile, my quartile 2. So 8, 11.5, another 8, 11, another 8, 10, 9.5. That's my third quartile. So the interquartile range is Q3 minus Q1, or it's that middle 50%, right? So remember, each of these is like 25%. And the interquartile range, or I'm just going to say it's the IQR, that's when we take the top 75%, or the 9.5 here, and we subtract the bottom 25%, or the 7. 9.5 minus 7 is 2.5. And if we look at this data, it says 15 people were surveyed to find out how many hours they sleep every day. The findings were as follows. Right, that's our data. Find the interquartile range and interpret what it means. Boy, so what does that mean? So we have 2.5 hours, that's the range. Okay, but what does that actually tell us about the data? Okay, so we can interpret the range by saying that about 50% of the people in the study sleep from 7 to 9.5 hours each day. Okay, so read that back. About 50%, okay, and that's because I'm doing for the middle 50% here of people in the study sleep from 7 to 9.5 hours each day. The difference in the number of sleeping hours among the middle 50% of the people is at most 2.5. Okay. So this one's kind of important because this is really what explains that number. We'll do it in blue. Okay. The difference, let me scroll down a little bit. The difference in the number of sleeping hours among the middle 50% is at most 2.5 hours. And we say at most because if I look at my data, these two people, right, 7.4 and 8, okay, those two people are in the middle 50%, but their range is 0.6, right? It's much shorter. So at most is the highest, subtracting the smallest, right? Or 9.5 minus 7. Okay. So this in purple kind of tells us what Q1 and Q3 mean. Okay, and then this sentence here uses that interquartile range. But you combine both of them together, that's how you get um, your answer, okay, for interpreting the interquartile range. And this is our last example for understanding quartiles. And let me zoom in a little bit. So for example 4, we're asked, concert tickets were priced at $100, $70, $60, and $45. 22 tickets were sold in the first hour of sales. The table shows how many of each type of ticket were sold. We're asked to find the lower quartile, the upper quartile, and the interquartile range. So that is Q1, okay, and the upper would be Q3. So that would be the upper and the lower quartiles. But in order to find those, we really need to find Q2 anyway, right? So we might as well. Now, if we take a look at the table, that shows us kind of a condensed version of the data. But in order to find the quartiles, we have to um, uncondense that that table. So we list them out. So you have 11 $45 tickets. So I listed out 45 11 times. Then you have five $60 tickets. So I did 5 60s, 4 70s, and 2 100s. And that's all my data. Okay, so now that we have our data listed, we can go ahead and separate it into quartiles. Now I know it says that there are 22 tickets. That means I can break them up into 2 groups of 11. 22 divided by 2 is 11. So what happens with that 11th number? Let's see, 45. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here is where I'm separating the group, right? There's 11 on this side, 11 on that side. The problem is that there's no number where I'm separating them. So again, just like before, because we had this problem before, we are going to take 45, add 60, right? We're finding the mean between those two numbers and we're kind of making up our own number. So 45 plus 60 is 105. We divide that by 2, and we get $52.50. And now I have them separated into 2 groups. And what I do next is I separate each of those groups. So each of those have 11 numbers. That means that the 6th number that I see should be the middle. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, just to make sure. So 45 is my lower quartile. And the same thing here. 1, 2, 3, 4, 5, 6. That's my Q3, which is $70. So that means my interquartile range, my IQR, is right my upper quartile minus my lower quartile, which is 70 minus 45, which is then 25. Okay, so the interquartile range is $25. And then it asks me to interpret what the interquartile range means. And this means that the difference in price among the middle 50% of the number of tickets sold is at most $25. And I just wrote it out for you there. So the difference in price among the middle 50% of the number of tickets sold is at most $25. And that's it for the notes portion of this lesson. What you're going to do is just one extra on your own problem where you are finding the interquartile range and interpreting it for these 50 multiple choice questions and the 19 students that scored the following numbers of correct answers. Once you have that, you check with your teacher, and then you can move on to the practice problems.